Hola amigos! So what do we have here? Sapphire R9-380X. This is one of the 13 graphics cards I bought early in November from eBay, all spares or repair. And we've looked at 4 of them, which are all waiting for parts now. 3 are waiting for parts, and we need to have another look at the GTX1070 Ti to determine if it's got faulty RAM or memory controller or bad BGA rework, basically. But I thought we'd look at one of the other ones today, and then we can have another look at. I'm sure some of the parts have actually arrived now, so we can go back and revisit those ones. So this one was sold as spares or repair, and the seller says that it gives a picture in the BIOS, but gives a black screen when the driver's loading Windows. So we can have a look at it. We have a model number on it. What is it? Oh yeah, R9-380X 8G DDR5. Okay, so that's what it actually is. So anyway, regardless of what the seller actually says about this, before I actually plug it into a PC and see if that's actually correct, let's have a look at it. So we'll take the heatsink off, we'll check the general physical condition of the card, and we'll look at the resistances, and then we can give it a try. Yeah, let's see what we get. So all the screws are in place. That's the first thing I'll say. There's no warranty still on any of them. I'm not sure if there would have originally been. So from this side, it's not possible to say if it's actually been opened up before. I don't know. It looks in better condition than some of the ones I've bought. This owes me about, I think it was £76.50 plus the postage. I've got the paperwork somewhere, so it probably owes me about just over £80, £85, somewhere in that region. Yeah. So let's see if we can get some money out of this one. Okay, I'll take it apart. Okay, I've got all the screws out, obviously. I think it's just held together by the paste now, basically. There's maybe one other. Yeah, okay, a couple of screws at the top, just one moment. In fact, now let's just do it. As you can see what's going to happen here, so we can just take these out. Okay, it's one of them. And the other one. And then let's look together. Let's see what this is like. Yeah, okay, that's definitely free now. Cooling fan. Okay. So this looks rather clean to me. I'll zoom the camera down in a moment so we can have a look around it, but this possibly looks like it's not been messed with, shall we say. Yeah. Okay, let's zoom down, let's have a look. Okay, is this a fuse up here? Not sure. Looks like it could be a fuse or something like that. We can have a better look at that, I think, just to check it for resistance. I think I can see some fuses the other side as well. So what is this thing? Well, it reads like a fuse. It reads like a good fuse. Yeah. There's definitely some more fuses here. So let's have a look at these. Let's put the blipper on, yeah. So well, that reads like a good fuse. So there's that one. So there's that one. What about this one? Yep, they all read like good fuses. They read okay. We've got the 12 volts coming here. Let me just arrange the meter where you can see it one moment. There you go. So the 12 volts obviously coming in here, and I'm sure that just goes to these fuses. I think it's probably the bottom there where the 12 volt comes in. Yeah, it's going to the fuses. Yeah, so we can check from these fuses to ground for shorts. That's the first thing we could do. So just put the black lid onto ground, and let's have a look at what we've got. So there's no short there, just a capacitor charge. I'll just turn the meters to the normal resistance mode. Let's see. Yeah, there's no short there. Nothing on that one, short. No short on that one. No short on that one. Next one is the 12 watts on the PCIe, which is the first 3 fingers here. So we can just go on to one of these. No short there. Next one is the 3.3, which is the 4th finger in here. Oh, the meter give me a sensible reading. Like 1, 2, 3, 4. Huh. It's like it doesn't want to read that. Now on normal ohms range, it's 1, 2. I consider this has not been plugged in, not by me anyway. It's been lying here for a couple of months. I don't really understand why that doesn't want to get a resistance reading on that meter. Get the other one. Get the other one. This one. Let's see if, what this will do. Resistance. Okay. Ground. 4th one in. 1, 2, 3, 4. Well, that's strange. It first read like it was a low resistance, but now it's charging up 340 ohms. Okay, just go the opposite way around in case there's a capacitor charging somewhere here that's giving me some strange readings. Yeah, 325 ohms. Well, there's not a short. Why my fluke meter does not want to read the resistance on this pin is a little bit, I'm a bit unsure. 1, 2, 3, 4. Oh, it doesn't like it. Oh, that's something wrong with my meter. It's very strange, isn't it? 1, 2, 3, 4. Oh, just like it doesn't want to. Just get it off the desk. Let's just pick up some interference from the anti-static mat, do you? No, it's just acting very, very strangely. Okay, really not sure. There can't be any voltage on this, surely. I mean, I'd say it's been sitting around for months. Let's just put it onto volts range. Let's just go again to ground and onto the 4th pin. Oh, nothing there. I'm using the DVI connector or whatever it is, HDMI connector, one of them for ground. So that should be a good ground. Yeah. This has me puzzled, guys. Suggestions in the comments, yeah? Why will this meter not read this? And why is my phone ringing? One moment. Sorry about that, guys, interruption. Okay, so yeah, meter's acting rather strange. Okay, well, let's continue. So these coils here, 1, 2, 3, these are all going to be on V core. I'm expecting this to be quite low, like, yeah, a couple of ohms or so. I think about 2.5 is correct for this type of processor, GPU, sorry, yeah. This one here will almost certainly be the RAM, and the easiest place to measure it's going to be underneath. So we'll get onto this one. And we'll just go to ground again. What's this reading? About 60 or something? Let's have a look. 95 ohms, yeah, 95 ohms, 95.5 ohms. That seems very reasonable for the RAM. This one, probably the memory controller, which should read quite low, about 20 odd, I think. Let's just have a look. Okay, 42.8 ohms, yeah. So that sounds very reasonable. There's a smaller one up here, so we can look at that one. That's here. What's this reading? Probably quite high. Yeah, that's reading in the kilo ohms, yeah. 7 to 8 kilo ohms, that's reading. We have 2 small ones. One of them I'm sure will be the PEX supply and could read about 20 odd. I'm not sure, let's have a look. This one's reading 165. This one's reading, just find here, there's the end of it. 7K, yeah, 165. Well, that's what we've got on there. There's certainly no shorts. That's the first thing we can say. We don't have any short circuits anywhere on this. Which, if what the seller says is correct about this card, you wouldn't expect to find. Yeah, these two I'm sure are just filters connected to the 12 volts. I'm certain that's what they'll be, rather than inductor. You know, they are inductors, but they're not regulators. Yeah, these are. Yeah, that's going straight to the 12 volts. You often find this. And you often find another one down here somewhere that's connected to the 12 volts coming in. It might be one of these. Okay, yeah, so resistance look okay. Looking around the board looks okay. It's a bit sticky, that's okay. So I think I'll just power this up first. So let's just see if it actually does do anything. If so, we'll put the heatsink on it and we'll see if it's actually doing what the seller said it was doing. Okay, so I've loaded Windows. I'll just make the inset a little bit bigger actually so you can see it more easily. Okay, so yeah, it looks like the computer isn't effectively seeing that the graphics card's there, even though it's actually giving a picture out of the HDMI. If I also ran Specky, and Specky seems to be sort of saying pretty much the same thing really. So let's try and install the driver on this, and let's see if it actually then detects the cards, or if it even allows me to install the drivers. Okay, I'll give that a go. That didn't go well at all. So I installed the drivers and it went pretty much all the way through, you know, like it installs the drivers, it switches the resolution of the screen to 1920, and then just before the driver finished installing, it crashed and went off and went black. And after that, I couldn't get it to work anymore. I can't get any picture out of it. It's just giving me a black screen. If I disable the onboard video on my motherboard, it just gives me like one long bleep and three short ones. If I leave the onboard video enabled, I don't get anything out of the HDMI anymore. Just don't get a picture. I get a single bleep, and if I connect my monitor to the onboard video, I get a picture. So something's happened, yeah. When I loaded the drivers, when it crashed, something's happened, and it just no longer wants to work. So let's open this up and let's see if we can see what's actually happened to it. Okay, so I've got it opened up again. Let's just disconnect the fan. So there we are. So I'd put some fresh, bit of fresh paste on this. But it's not exactly on the middle very good. I'm not sure whether that's just because I've just taken it off. So let's have a look again. So I made some resistance measurements on this, obviously, and I've just made a note of all the ones that I took. So let's see if we can see any difference between what we had before and what we have now. So go to ohms range. So the main ones we can see, and we know there's no shorts. I mean, it doesn't stop the computer from powering up. The 12 volts coming in was previously reading about more than that. There's a fuse gone. Yeah, the fuse is gone. There's a fuse here, that's gone. What about these fuses up here? That one's okay. That one's okay. That one's okay. That one's okay. But I've got a fuse down here that's gone. So look at the other resistances on this. So V-core, I was reading about 2.4 ohms. What have we got now? Yeah, I mean 2 ohms, you know, it's close enough. And there's always a little bit temperature dependent as well. Yeah, 1.9, 1.9. So that's okay. This is the RAM phase up here. What's this one reading? Get up to the ground again. Yeah, that was reading about 95 before, so that's close. Probably the warm just a few degrees warmer in here today, that's always will be, and slight differences, so that's okay. This one at 165. Yeah, 175, we can live with that. This one here was reading quite high, 6.8K. Let's go over to the 6.8K, yeah. This one is reading whatever it is, 42.8 it was reading previously. 46.4, yeah, it's fine. This one was reading, well, there was another one somewhere on here, yeah, top here. That's this one. This was reading high, about 700 kilo ohms, 46 ohms. Oh, that's interesting. I'm sure that was reading a lot lower than last time. 46 ohms. 46 ohms. Let me just refer back to the video and just check that. Well, I've referred back to the early part of the video and the resistance measurements I made. I've also looked up a bit of information on the internet as to what these various voltage rails on this card actually are. We clearly have a blown fuse, that's for sure. So we need to find out why. Now, these coils here, this one is actually just a filter inductor. So the 12 volt comes in here and it goes to this inductor and then goes to this VRM here, this buck regulator. And we can just check that. If I just get on the end of the finger under here on the 12 volts, and this is the actual coil. You can see on the meter if I just get onto it correctly. I'm on the. I need to use the other end of the fuse, guys, because the fuse is blown. I'm now on the fuse, and I'm now on this coil here. And you can see that goes to the fuse, so that connects to this fuse. So the 12 volt comes through the fuse, through this inductor, and there's a regulator here. But this 12 volts will also go across the board to all the various other, you know, the V core, the VRAM, PEPs, and whatever. Now, looking at the resistances on these inductor coils, and I'll just go through them again. So this one over here, this is actually the memory controller. And if we go to ground and measure this one, this should read about 44 ohms, and I'm getting 46. Yeah, this is off readings taken on a good card on another video. So that should be reading 44. I've got 46. That's okay. The regulator, this one here, this is the 5 volts regulator. So 12 volts comes in here from the fuse, which is blown, and goes out here as 5 volts. And this is reading about 14k, and that's quite normal for that. In fact, it may be slightly higher. I think normally should read a little bit lower than that. I was getting told of reading maybe 6k, 7k. I'm actually seeing 14k, but it's not assured. This chip here, this is the 1.8 volt regulator, and the 1.8 volt comes out on this pin here, and this should read around 200 ohms, 212. Yeah, that's reading correct, so that's okay. This is your PEX supply, this one, the 0.9 volts, and this one should be reading about 165. I've got 168. Yeah, that's good. The VRAM up here, and I can guess at the top end of these inductors here on these, that's reading 96. Now the one I was looking at was reading about 130 on the VRAM, but it's possible it's just a different type of RAM. I don't know for sure. That's reading lower than expected, but that's not unreasonable for RAM, and maybe it's down to the brand of RAM. But I'm not too worried about that again at the moment. Your V core, and I'm now on resistance range, not on continuity, and this is now reading about 2, and it should be reading about 4. So it's possible I do have a problem there with that. That is possibly a problem. So I don't know. I was reading about 2 before, but I have had it reading 4. It's strange. No, it's definitely reading 2. Okay, well, there's not a short anyway, so much as we can say. And we did get a picture out of it before, and that's basically what it was reading previously. So I can't see how that can be wrong. So what we come down to the fact is then that this fuse is blown. All those resistances look about right compared with another one, and certainly there's no shorts on any of them. So why is the fuse blown? Well, from this end of the fuse, we're reading 47 ohms, that sort of thing, yeah? So there's not a short to ground, but there is a short. This should be reading in the kilo ohms. So let me sort of just explain to you why I know there's a short and how we can figure out where the short actually is. So on the graphics card, the 12 volt is one of the main supplies coming in. But all the various components on the graphics card, the GPU, the RAM, and anything else, the logic circuitry, don't run on 12 volts, they run on lower voltages. And that's what these VRMs are doing for the V-core, for the RAM, for the memory controller, for the PEX. And then obviously there's a 5 volt regulator, there's a 6 volt here, and there's the 1.8. So those are actually generating the voltages that the board actually runs on. And most of those regulators are what are called buck converters. So effectively you've got your 12 volts coming in, okay? It comes in from the PCIe, it comes in from the 8-way connectors as well. And they will supply the various VRMs on here. And each VRM basically looks like this. So you have 2 MOSFETs, high side and low side, going to ground, okay? And the gates of these will go to the pulse width modulator, the controller that controls that VRM, okay? And from the middle of here, you'll have the coil, and that will go to the load. So for instance, this could be going to VRAM, okay? And it's possible you have more than one phase. This is a single phase. So you can have, you know, multiple phase controllers. You can have another one of these sort of down here, just draw it for you. Okay, here's your gates again, to put your MOSFETs in. And these will go back to the PWM. So we've now got a 2-phase. There'll be another coil here. And this point is connected to this point. They're both connected together. This is VRAM. And on our board, we actually only have a single phase for VRAM, but you can have 2 or more. And then we have 6 phases here, all for V-core. So imagine there's 6 of these, yeah? Also off the 12 volts, this will be powering the other rails. So we'll have same sort of thing. Okay, to ground. Put the ground in. A bit of lopsided. 2 FETs. High side and low side. The high side goes to the 12 volts. The low side goes to the ground, yeah? And we'll have here another controller. And our gates will go to that one. Again, there'll be a coil. And this could be a VMEM controller, yeah? And we'll have, again, another one. We'll put it in. To ground. Gates again, 2 MOSFETs. High side, low side. And the same thing occurs. Pulse width modulator to the gates. Coil from here. This one can go to V-core. Okay. On the 12 volts coming in, there will be capacitors. Lots of them. Okay, going to ground. These are the little ceramic ones and sometimes electrolytic capacitors. And there'll be lots of these capacitors going to ground. Now, this can go short in different ways. We know on our board, for instance, that the RAM is reading about 95 ohms, okay? We know the memory controller is reading about 43 or 46, whatever it was, yeah? And we know the V-core is about 2.1 or 4, depending on when I read it. Okay. So, those are the resistances from each of these coils to ground through the load, yeah? Imagine that's the load. Again, I'll do it that way up to ground, yeah? So what you can measure from here to ground is the resistance of the load. Okay. Now let's consider a short. That's how it should work. So on the 12 volts, we should see a high resistance because the 12 volts only goes into these when the MOSFETs are being turned on. And it's not powered up, they're all turned off. So this should be high. In our case, we see in here about 43 ohms or 46 or whatever it was, yeah? Where's the short? Well, look, 43, 43. Do you think there's any coincidence those two readings are the same? And the answer is no, it's no coincidence at all. If one of these capacitors went short circuit to ground, here you would see 0 ohms, yeah? Okay, because the capacitor's short straight to ground. If one of these MOSFETs, the high side MOSFETs, went short, yeah, through there, what you would see now is the resistance of the load because there's just a wire connecting from here to here. There's your short. So if this one went short, what would you see from the 12 volts? You'd see 95 ohms. If this one went short, what would you see? 43 ohms. If this one went short, what would you see? Go on, answers in the comments below. 2.1 ohms. So by looking at the resistance here and then measuring the resistance from each coil to ground, the two that match, there is your short circuit high side MOSFET. And that's what's wrong with our board. So let's have a look now at the MOSFETs on the VMEM controller and let's see if we can find the short. Here then is the memory controller phase. This is the coil. And if I flick this board over upside down, we can get a bit of focus on it. We don't need to even bother focusing. This is the coil, yeah? Now if I go to ground and I go to this coil, we read 46 ohms. Okay, it's 46, not 43. So from here to ground is 46 ohms. This is the actual driver chip, this thing here. Let's just get the part number of it. Can we just focus it? You'll see it. There you go. It's an IR9-380X. So let's have a look at the data sheet of this device. Okay, so this is the actual data sheet. So we can see here we have a tab here which is V in. This is the 12 volts coming in. This tab is ground, and this one SW, if you look, SW, this is the one that goes to the coil. Okay, all the ones on this end. So from here to ground we should read 46 ohms, yeah? From here we should see this goes to 12 volts, but from V in to switch there should not be a short, and this is where I'm sure we have the short, because this V in to switch, this MOSFET internally will be short circuit. Okay, so let's actually have a look on ours and let's see what we actually have. Just go over to the microscope again. Okay, so we can see, and we've got the meter where we can see it. This point here, it said was ground on this tab. Okay, so I'll just get onto the ground. So this is ground. And we're reading, yeah, 0 ohms pretty much. I mean, it's not, yeah, it's 0 now, 0 ohms. Okay, so 0 ohms on there. This one here coming in, this should be the 12 volts, and we can see we're reading 46 ohms. If I go back to the fuse, you can't see where I am, but I am on the fuse. So if I go back to the fuse, and we can see the 12 volts comes into here from that fuse. Okay, so from here there should be no connection to the coil, and there's our short. Okay, you all need to is there's our short circuit, and that's why from the 12 volts or the side of the fuse connected to here, we're reading 46 ohms. And I hope you see now how simple it was to work out where the short circuit MOSFET was by the measuring the resistance of all the coils. So to fix this, we need to replace this device, and we need to replace the fuse. These fuses are 10 amp fuses. I'll put the actual specification in the description to this video as well. But those are 10 amp fuses. And we've got the part number for this one, IR3553M. So let's go and have a look on AliExpress and see if we can actually find some suitable components to repair this card. I mean, one interesting thing is that where this is blown, there seems to be like a bit of something there probably come off it. That looks like it's part of it originally, maybe come from underneath it somewhere. Can't we get the microscope to focus, but I suspect that's come off there somewhere. Okay, so I had a quick look on AliExpress, and these chips are not expensive. So this is the fuses to start with. This is the actual type of fuse, 0451010.MRL, okay? And they come in a variety of different ratings. These are 10 amp ones. And you can see I can get 5 of them for like €1.68 plus a bit of postage. So I'll probably just order 10 of those. They're not expensive. And I'll get the 20% off anyway. Sorry, 21% off anyway, because I don't pay the VAT. These are the actual chips, IR3553M, €4 for 10, plus postage, $5.52, again less than 21%. So I can order 10 fuses, and I can order 10 of those for less than €10, probably because we're about €8. So I'll get those ordered. The question then really is to why did it fail? I mean, the chip itself is a combined sort of MOSFET driver and the MOSFETs itself, and this thing internally is blown short. It has an external pulse width modulator controller that drives it. My first thoughts about this are that maybe this had a problem anyway, which is why the thing wasn't detecting when it was under load. It was on its way out. Maybe the voltage of the memory controller was unstable, and that's why it was crashing as soon as we loaded the drivers. And then this time it just failed. I mean, it's not a catastrophic thing. This was running for 15 or 20 minutes and it just went. And I don't think it's like a catastrophe, like effectively something in the GPU went short. So guys, that one's going to be waiting parts as well then. We can just wait until they turn up, take a few weeks no doubt. And then, yeah, let's replace the fuse. Let's replace that chip. And then let's see what happens. I mean, I've ordered a number of them, so if something else is wrong, hopefully we can then work out what caused it. Yeah, my guess is that effectively was failing anyway, hence the instability, or it wasn't working properly. And then the fact it has just failed actually maybe has helped us to repair this one if that solves the problem. So that's another one of the, that's the 5th one I've looked at out of the 13 that we have, faulty spares or repair. And so far, they all look to be repairable. Obviously, we'll have to wait until the parts turn up, but this looks like it has a good chance, considering it was working until that went. There's a good chance this might work, might be repairable. Okay guys, hope you enjoyed that one. Sorry I couldn't fix it today, but I believe it was a good diagnosis, and hopefully you've learned a little bit about tracing where the short circuit is, whether it's a MOSFET. And I'll see you all soon on the next one. Hasta la vista.